Okay, so I am Dr. Littman. You can call me that. You can call me Mike. You can call me Yo Fatty. I don't care. I'm not a very formal person. So feel free to call me whatever you want. I do, as I heard somebody mention, I record every one of my lectures and I put them up on YouTube, and then there'll be a link on Blackboard so you can watch all the lectures. If you want to see the lectures from last semester or last year, spring 2018, CSC200 is up there. If you want to listen to that for inner meaning, that's fine. And I'm screen capturing my actual screen, so you'll just hear my voice and then see what I'm doing on the actual screen. I'll also share these slides with you, so you have a link to the slides up there as well. I'm supposed to take attendance every class. I don't. You're all adults. If you don't want to show up, that's on you, but I do give pop quizzes, and quizzes count as part of your homework grade. So Blackboard's already open. You guys should be able to go on there and look at the syllabus, but the grade breakdown for the class is 60% homework, 20% midterm, 20% final. So if you don't show up to class one day and I give a pop quiz and you get a 0 on it, that's 0 for a homework assignment, which is weighted as 60% of your grade. There will be extra credit opportunities throughout the semester, so you probably get a few get out of jail free cards type things there, but you skip class, it's on you, that's fine. I'm not going to come hunt you down or anything like that, just your grade will suffer. And it's pretty common when there's a lot of people skipping class that I will just give a quiz that day anyways. And sometimes it's one of those freebie quizzes, like pass around a piece of paper, just write your name on it. That way all the people who skipped really suffer. Yeah, because I find that funny. That's what it comes down to. For most of you, this is the first time you've had me. You'll find me to be a little bit different than Dr. Locklear or Professor Locklear or Dr. Wall, who you maybe have had before. That's probably a good thing. They're not funny, I'm funny. How many of you had Dr. Locklear? Man, isn't that funny how he has to tell you on his slides to laugh? Oh my gosh, it's terrible. Plus he's old, he's so old. It's all recorded, it's fine.
It's all recorded.
No, Dr. Locklear and I have been working together for 13 years here, so we're mortal enemies. So, let's start talking about stuff. So I mentioned that 60% of your grade's homework, 20% is the midterm, 20% is the final. There'll be a lot of programming stuff on both of those tests. Programming is hard, okay? Many of you are going to really, really, really suck at programming for a while, all right? Having said that, I have a policy where if you do better on your final exam than you did on the midterm, I'll replace your midterm exam grade with whatever you get on the final. Okay, my job is to give you a grade at the end of the semester that's based on how well you've mastered the material. I want to give you every opportunity to show that to me. Okay? You will spend a lot of time on homework and things like that in this class, again, because programming is hard. This isn't the type of class, computer science in general aren't the type of classes, but certainly the programming classes, they're not the type of thing you can just cram for. Okay, you can't show, losing, something?
Oh, nothing up there.
Where we're at? Oh, that's perfect. I love reliability. Yeah, so it's not the type of thing you can just cram for. How many of you play a sport or a musical instrument or something like that, or can relate to that type of thing? All right, somebody who plays a sport. What sport?
Baseball.
Are you pretty good?
Yeah.
Okay, you're like legit good, or you just kind of is this like a delusion thing? You're like legit pretty decent, right? Okay, are you a lot better now than you were when you first started?
Yeah.
Why?
Practice over time.
Okay, practice over time. So when you first started, you kind of sucked, right? Okay, you didn't know how to do all the things. Now, could you have sat there, I assume before you really started playing baseball, you were probably a fan of watching baseball like on TV, right? Okay, now did that really help you become amazing at baseball? Like, could you sit there and watch, 500 hours of Major League Baseball, then go out there and maybe make a run at a AAA team or something like that? No, you're going to still suck, right? If you're looking at basketball, if you've never played basketball before, you can't just go hang out at Michael Jordan's house for 10 weeks and all of a sudden you're ready for the NBA draft. Okay, you can academically learn a bunch of things, right? You know, how you're supposed to hit a ball down the left field line or something, you know, this kind of stuff. But until you've actually put in the reps, put in the practice, you know, found out all the things that don't work for you, your body type, things like that, you're not going to get better at the sport, right? Programming is a lot like that. Okay, you're going to spend a lot of time writing things that are actually pretty simple to do, and you're going to spend 5 hours on a homework assignment, not get it working. Then you're going to show up to class, you're going to see me solve it in 45 seconds, and you're going to be like, that was it. It's going to be extremely common that you will completely understand the solution when you see it, but when you sit down to write it yourself, you'll struggle with it. And we're going to talk about why that is today. But no, I've been doing this for a few minutes. I've been teaching for 20 years. So I've been teaching computer programming specifically for 20 years. So just trust that I realize you're supposed to suck for a while. Okay, so as long as you put in that effort, and I see that effort being put in, I'll let you know if I think you don't have what it takes, but I care less about the specific grades like on homework. Homework is your practice. It's my way of kind of judging your practice. I'm not going to knock you and rip you for all these points in your homework assignment. If you spend 5 hours on a homework assignment and don't really have much to show for it, I'm not going to give you a 20%. Okay, so with all my homework assignments, I have this self-evaluation that you turn in, where you get to tell me about your experience. You tell me what works, what doesn't work, how long did you spend on this thing, you know, and in your description of what doesn't work, I'm going to get a pretty good feel for the things that you tried. Does that make sense? So if it becomes fairly obvious to me that you put in a lot of practice there, a lot of effort, tried 50 things, and they just happen to be the wrong 50 things, I'm probably going to give you a 90% of the homework. I might even give you better than that, because I want to reward you for putting in those reps. I'll find out on the exams if you're cheating on homework assignments and things like that. Okay. Having said that, I encourage you to work in groups. Okay. Every semester, there's usually 2 or 3 different study groups that get together. If 5 or 6 of you want to get together and work on homework, that's fine. I don't care. I'm not going to sit there and look at the assignments and see whose matches whose. I'll find out on the exams. So we do have a Slack channel. So if you go to cuwcs.slack.com, what am I on? Guest again? Yeah, I am. All right, so you go to cuwcs.slack.com. You'll be able to, let me log out of this. You'll come to a site kind of like this. And you'll want to create an account. So go here, create an account. You'll put in your email address, the @cuw.edu one. Say create account. If you have that student.cuw.edu one, just omit the student part. Just put whatever's before the @ sign. Okay, that'll create an account for you. Then you'll get into our Slack channel, and you can download. You can either use Slack on the web, or you can download apps for your phones, tablets, computers, whatever. App looks like this. There's already a channel in here for CSC200. So double click on that channel. You will have joined the 200 channel. I will make announcements and things like that in here. Okay. But if you are interested in a study group, I'd encourage all of you to go ahead and create an account. You should all create an account anyways, because sometimes I will make important announcements in here, and I'm not going to always send emails because that takes me longer. Okay. And this won't take you very long, and all the teachers in the department should be using Slack, even though they don't all use it. But in any case, go ahead and post in here that you're looking for a study group, some people to work with for your homework. Form a group. Maybe when you get together to work on homework, somebody will say, hey, we're going to get together and that's beautiful, at the Nest for tonight at 8 p.m. to work on homework. Show up, work in a group, but show up with the intent of learning. Some of you are going to catch on to the stuff quicker. Some of you maybe have had some computer programming in the past. You'll get better by helping those that are weaker or are more, that are beginners. Those of you who are beginners, don't show up to those groups with the goal of just getting your homework done, because you will bomb the exams. Okay, you'll get a 10% of the exam, and it won't matter if you had an A homework average. Okay, you'll still bomb the class. Make sense? The goal of homework is like baseball practice, basketball practice, playing a musical instrument. You got to put those reps in, you got to put the time in, and expect to spend more time in this class than you might in other 3 credit hour classes, not because I'm giving you homework that should take a really, really, really long time, because you'll see me solve it in class in just a couple of minutes. So you'll appreciate that this wasn't that much work, but when you first start, it's going to be tough for you. Everybody trust that? We're good? Okay. So in 3 weeks we'll talk, and we'll say we'll find out like 80% of you won't do the study group thing, and like, oh, I can't do this stuff, I'm not good at programming, and I'll remind you that technically day 1/3 or whatever, I said join a study group, and like, oh well, I thought I could do it myself. Join a study group. It'll benefit you. Okay? Take advantage of the fact that your teacher's not looking for cheaters. Get your homework done, get a high graded homework, and actually learn by accident along the way. Okay? All right. So, questions about the class. Go ahead.
Does Slack fire you an email when you post in there, or do we have to just periodically check?
It won't send you an email, it does push notifications. So if you put it on your phone, like I use it on my phone majority of the time, it'll pop up saying there's a new message in a certain group. You can go into each individual group here. So like 200, I think I click up here, then I click on notification preferences, and I have this set to receive all new messages on desktop as well as my mobile device. Okay. You might not want that on like general or something like that, because sometimes people will post job opportunities and things like that on general. So you might decide that you maybe set all notifications up for the classes you're in, and then maybe you just do, if your name is mentioned or something, for everything else, and then you periodically will just notice that somebody posted in general, because it'll show up, it'll show up like in dark white, so that you see there's a new message in there. All right, but you'll get a push notification, kind of like a text message. Sound good? All right, any other questions? Go ahead.
So how do you get to this site? Because I actually tried it. I actually did it manually, and it said like the website was not secure.
How do you get to what site?
Slack.com.
cuwcs.slack.com.
That's what I put in, and it was.
It should be HTTPS.
Oh.
But if you just type in cuwcs.slack.com, it should change it over to HTTPS automatically.
Oh, no, that didn't do that. So.
But then once you sign up, I mean, you can use Slack on the web, like if you're in a computer lab or something like that, but I would put the app on your phone, put the app on your computer so you have easy access to it. Sound good? All right. So, let's dive in here. Everybody saw that the first homework assignment was up. You get the book. It's an online book from Zybooks. It's a really good book. Okay, I'm going to give you lots of exercises out of there, especially during the beginning part of the class while I'm talking about some background information in programming. But it'll benefit you throughout the entire semester. All right, so let's talk about computer programming. What does that mean to you? How many of you have had some programming before? A couple of you, actually. Fair amount. Okay, so what does computer programming mean? If you were to concisely define computer programming, what might you say?
Writing a step-by-step instruction for the computer to follow.
Okay. It's probably a pretty accurate description. I like to say it a little simpler than that. This is telling a computer what to do. That's what it is, right? Ultimately, we're going to be creating an algorithm, which is a step-by-step set of instructions. It has to be unambiguous and all this other crap. But at the high level, as a computer programmer, what are we doing? We're like a ninja, okay? Except instead of telling somebody else to do something or beating people up or whatever, we're telling a computer how to solve a problem. We're weaponizing our computer to take advantage of all the fast processing power it has and making a computer do something. Okay, so What's a programming language? Okay. Love that answer is a perfect wrong answer, but we'll come back to that in a few minutes. Okay. Tell me what I'm not asking for example programming languages. I'm asking you what is a programming language. Go ahead.
Place where you can type in code to create like a program or like tool
Okay.
that gives that you give it like certain languages or certain ways of allowing the user to give instructions and so.
Okay. So programming language is sometimes a synonym for that is code, right? You've heard of code before. Now, those of you who have programmed before, what languages have we programmed in?
C++.
Okay. C++, Java, what else? Python.
Oh, yeah, Python too.
So SQL, not a programming language. We'll talk about why in a second. Either is HTML, so that's good. Anything else? What's the best programming language?
Good question.
They're all good for different things.
Okay. I like the first part of that. They're all good. Every programming language is the same. Okay, we're going to learn about computer programming as a skill set. The language doesn't matter. In this class, we happen to use Python. In the next class, we're going to be using Java and Android programming. Okay, in the class after that, we're going to be incorporating databases and things like that into it. But punchline is, the language does not matter. Once you learn how to program, you can pick up another language in a weekend. And then after you've been using it for a couple of weeks, you'll be up to speed on it. Okay, so now programming language, this is the language that we use to tell a computer what to do. All right, so what's a language in general? We're all speaking in language in here, so we've chosen a language or a protocol. So let's talk about protocols for a second. So this is fancy name for language. Okay. Now, how many of you assumed that I would be speaking English to you when you walked in? Why did you make that assumption? Because we're in the middle of Wisconsin? It's like, gonna make sense. Okay. Decent chance that a high majority of the students in the class are going to share that same language. So you probably want to pick a protocol. How many of you in here speak Russian? Half a person. Well, 5.5 people if you count me. So I probably should not have. That's a fat joke. I know I seem petite, but in real life I'm actually quite large. So if I had come in and picked Russian, the class would have struggled, right? Yeah, when I was in grad school, I had a teacher. His name was Wandi Wei. He taught the entire class in Cantonese. I was the only American in the class. All the other guys were Chinese guys, and he just taught it in their language. That was an interesting class. This was at the University of Illinois. Yeah, so what are you going to do? Okay. But we agreed on a protocol, right? We agreed on English, even without speaking it, right? Even without like sitting down and saying, well, what language should we use? We just agreed upon a language. Now, English, along with Spanish, Russian, whatever, these are all natural languages, right? These are languages that human beings use to communicate with other human beings, okay? Which do you think is harder? Speaking to a human being using English or speaking to a computer using Python? Go ahead. What's your opinion?
Probably speaking to a computer because a human being can inference when there's missing gaps in the language that doesn't necessarily make sense, but a computer will just
Okay. So you think talking to a computer is harder?
Yeah.
Okay. Maybe harder is kind of a bad way to ask the question, because you probably could argue both ways. You will all find it harder to talk to a computer using Python. But the problem you're solving when talking to a human being is a far, far, far more complex problem than when we try to tell a computer what to do. Because human beings are really complex, right? Like when you're trying to understand what somebody's saying, you're not just listening to their words. You're looking at facial expressions. You're looking at hand gestures. There's all sorts of little nuances. You mentioned human beings can kind of fill in the blanks, right? Computers can't do any of that stuff, right? You have to be completely unambiguous to a computer. You have to go step by step by step by step and give it completely unambiguous instructions so that it can accomplish some task. Make some sense? Or with a human being, you can give pretty vague instructions like, yeah, you go down to Main Street, you hang a left, I'm like 2 or 3 lights down, there's a gas station on the corner, on the third house on the right, there's a pink Camaro in the driveway. A human being would probably find that house, right? Even though there was a whole lot of kind of sketchy details in there. Make some sense? All right, so this is a tool for communicating. Nothing fancy there. Okay, so I mentioned earlier that computer programming is hard. Why is it hard? Well, so when you took 150, one of the things that Dr. Locklear would have asked us is, what's computer science? Computer science is problem solving, right? All right, so that's we all got that one? And you memorized that? You got the point on the test? All right, so computer science is problem solving. So now, how many of you feel you're good problem solvers? Maybe I go the other way. How many of you think you're bad problem solvers? Or just don't want to admit it in front of the group? It's like, look, I'm just a spaz. Human beings, the answer to this question, why is programming hard? Human beings are so good at solving problems that we have trouble articulating how we solve them. To be a computer programmer, we have to be able to describe the solution to a problem in a step-by-step, unambiguous manner. And as good as we are at solving problems, we take for granted how good we are, and we've lost that skill of being able to articulate how good we are. So humans are so good at problem solving that we have trouble articulating how we solve a problem. All right, so I usually ask first day of class, how many of you got to class today without bumping into any walls? I usually get a couple of smart asses like, oh yeah. Okay, but what's the reality? You're walking to class, and what does it look like? Right? You're bobbing and weaving around people while you're looking at your smartphone. And maybe you bump into a wall here and there when you zig when you should have zagged or something, but in general, walking is trivial for us, right? We don't even think about it. Do you think walking is a hard problem? How do you walk? Try to give me instructions for walking. I want those unambiguous instructions so that we could teach a computer how to walk. So first of all, we have to define a whole bunch of things like what feet are, right? And they're attached to legs, and we have a whole bunch of joints between those. Now, when you're walking, do you think about all the little joints you're using and all the little muscles that you have to trigger and fire in order to get the foot to extend and all this stuff? Are you thinking about every single one of those things? Sure you are. It's just subconscious. Because you've done it so many times, so many times it's like muscle memory, right? So would you say that walking is incredibly complex? To the point where you would find it difficult, in fact, borderline impossible for a human being to truly write down an algorithm to accurately walk. You're going to leave something out. There's one of those little tiny twitch muscles that nobody knows the name of except unless you took that 3rd level anatomy class or something. Okay? There's a lot involved in walking, but we take it for granted because we're so good at problem solving that we just walk. No big deal. We don't even have to pay attention where we're going. Okay? How did you avoid bumping into walls? Maybe you just say, I just do. Okay? Well, what's the reality? You're walking along, you're kind of looking in front of you, you're taking all your senses into consideration, you're scanning the hallway. Is anybody coming at you? If somebody's coming at you, you might lean a little bit one way, lean a little bit another way to kind of swerve around people. Don't want to bump into walls. You kind of have this idea of how big you are, kind of like cats. If they can fit their head, they can fit their body. That type of thing. It doesn't work for people. I've tried. But the point is that you're asking all of these questions as you're walking down the hall to avoid bumping into people, to avoid falling over, to avoid bumping into the wall, right? How many of you actually hear yourself asking those questions? Or is it so passive for us that we've actually forgotten that we're asking them? We're doing it. We're just kind of on autopilot, right? All right, so that's why programming is hard. We're so used to solving complex problems in a way that feels trivial to us that we're no longer, we've lost the skill of articulating how to solve the problem, right? Simpler problems we might be able to articulate reasonably well, but one of the skills that we're going to have to gain in here is being able to slow down our mind and ask ourselves, what are the individual steps that are going to be required to solve a specific problem? And I promise you, when we're writing a program to tell a computer what to do, the programs we're going to write are way, way, way simpler than teaching a computer to walk. That's outside of our wheelhouse. Does that make sense? So you look at the most advanced video game that's out there, you know, pick your favorite first-person shooter or something like that that has explosions and all this other stuff going. That is a far, far easier program to write than to teach a computer to walk. That makes sense? In fact, how many of you have heard, this is on topic but slightly off topic, how many of you have heard of something called machine learning? Okay. What is machine learning? The couple that rose their hand, tell me roughly what you think it is. Go ahead.
Well, machine learning is an built program which is able to run a basic program over and over and over again and learn how to make that better each time.
Okay. So I just mentioned that there's some problems that might be borderline, you get the whole thing, nothing's impossible. Some problems that might be borderline impossible for a human being to write. Or extremely, extremely, extremely difficult. And there might be other problems that we really just can't even articulate how we can solve the problem. Now, let me give you an example of my first experience with artificial intelligence, neural networks, which is kind of that's the backbone to machine learning. Okay, this was years ago. We wrote a neural network, so that's something you'll do later on in computer science, but it's a programming thing. So we created a neural network, and then what we did is we fed it the multiplication table. You know, like when you're in, was it second grade when you learn the multiplications table, you have the flashcards, right? You know, like 1 times 2, 1 times 3, 1 times 4, 3 times 1, 3 times 2, 3 times 3, you know, all those guys. We fed it the 1 through 5's multiplication table. All right. Now, we didn't teach it anything. All we did is build this neural network with this kind of this weird blob thing. And we fed it some inputs, and it makes a guess as to what the answer is. Now, chances are it's going to get it wrong the first 1,000 times, right? And what do? When it gets it wrong, you slap it on the wrist, you adjust the strength between the neurons just a little bit. So that next time it'll get a little bit more correct. And you keep doing that millions and millions of times until you kind of balance this neural network to the point that any of the 1 through 5's multiplication table you feed it, it gets the right answer. Okay? Then we feed it data that it's never seen before. We fed it the 6 through 10's table, and it got 97% of them right. So that's an example of machine learning. We trained this neural network on the pattern of multiplication to the point that it now can do multiplication even though we never actually programmed it to multiply. It kind of figured it out. You know, a lot of times we'll call it like a black box. So we trained it, but we didn't use logic. We just said, we know what the inputs are. We know what the desired output is. We're going to keep beating you over the head with it until you get it right. And now you have this magical solution to something. And what are we using it for now? We're using it for like self-driving cars, things like that. These are things that are very difficult for us to solve or even articulate as a human being. You're driving a car. How did you know that you needed to turn the wheel at a certain degree so you didn't slam into the person over there and the dog over there and then the stop sign? All this stuff. We're training neural networks to do this. So we're letting these things drive our cars or land our airplanes that we don't even know how they work. They just do. Okay? Machine learning is actually kind of a really cool thing. It's going to be applied to a lot of different problems, but that goes to say there are patterns in problem solving. All right, so we're going to be solving, as a normal computer programmer, 95% of the problems we're solving would be considered fairly trivial problems. That 5% that we would call harder problems are so much easier than walking. Okay? We would just call them kind of hard computer programming problems. They might be fairly mathy, things like that. All right, so that's why programming is hard. It's because you're too good at problem solving. So one of my goals in here, and I mentioned that you're going to have to spend a lot of time on homework and things like that, because we're going to have to slow your mind down. We're going to have to train you to take a step back. Don't immediately dive in and try to start writing code. Instead, try to write down the 5 or 6 individual steps that you have to take. Then convert that into pseudocode. Then turn it into actual code, whether it's Python, Java, C#, Swift, whatever it is. Okay? That's not going to be comfortable for most of you, because you're going to want to jump in and immediately start solving a problem, because that's how we do it in real life. In real life, we've gotten really good at solving problems. You don't stand up and say, okay, let me get my bearings going here. I'm about to walk, right? You just go. Well, unless there's been alcohol involved, and then there might be some problem solving involved. All right, dry campus, don't do that. Okay, so make sense why programming is hard?
Yes.
All right, so trust me on that. Next guy here. How do human beings solve problems? I like to break this down. I kind of abstract this. Remember in 150, the abstraction slide that had, what was it, Einstein on it? Still Einstein? Who was Einstein 15 years ago? Same slide. He's got like 19 grandkids since then. He just got a new grandkid. Yeah. Did you know that? Professor Locklear had he didn't. His wife had a baby. So Dr. Locklear has another grandchild. So how do human beings solve problems? We use our memory. We ask questions. And we use repetition. All right? Now, we see it in movies sometimes. They kind of make fun of it with people with like short-term memory loss. Right? When you walk into somebody, they say, hey, I'm Carl. And then 2 seconds later, you just say, hey, I'm Carl, because you forgot you ever met him. Kind of like the goldfish effect. But how debilitating would it be if you didn't have a memory? Extremely, right? If I asked any one of you in here what your name is, you'd know it. What your phone number is, what your address is, what your shoe size is, all these things. These are pieces of information that you have stored up inside your brain. Now, you don't wake up every single morning and go through the what's my name flashcard and what's my age and all those things. That's just in there, right? As you get a little older, certain numbers get flipped over. Like if you don't use your social security number enough, sometimes you got to say, well, is it 5'5" or 5'7"? You flip-flop some stuff. But generally, you're not waking up every day practicing, these 5,000 bits of information that you've stored, right? You've used your memory to hold that stuff in there. And sure, we forget about unimportant things, but some of those main things just kind of stick in there. All right, so we really rely on our memory for solving problems. Asking questions, we mentioned a little bit ago. Even when you're walking down the hall, and even though you're not really thinking about it, you're constantly saying, okay, am I going to hit somebody? I'm going to hit somebody. Do I need to go left? Do I need to go right? Am I going to fall over? Am I losing my balance? Is there a wall over there? You're asking a zillion questions about everything that's happening around you. You have all these senses. So we have our eyes, we're observing stuff, we're smelling stuff. You're probably not going to run into a room that smells like smoke, right? Something like that. So we have all these inputs that are coming in constantly. And we don't recognize that we're asking questions about it, but we are. Everybody in here believe that? We've just gotten so good at problem solving that stuff's out of our mind. We're not going to pay attention to that. Okay? So we ask a lot of questions. Repetition. We're creatures of habit. There's a lot of things that we do that involves us repeating the same steps over and over and over again. And this is really the leverage point for when we look at computers and say, you know what? That is a pretty tedious task that, yes, as a human being, I can do that, but I don't want to do that. So now what we can do is we can take that computer that doesn't need to sleep, that doesn't need to eat, that doesn't make mistakes other than the mistakes that the human told it to make by writing buggy software. And we can leverage our skill in computer programming to tell that computer what to do. All right? So this is how human beings solve problems. So what's the job of the programming language? Allow humans to speak to a computer in such a way that they can let's say that they can tell a computer what to do in a way compatible with how the human already solves problems. And remember, I'm giving you a link to these slides, so you'll be able to bring them up whenever you want. They're online, so don't feel like you have, feel free to take notes. Just if you miss a word, you're going to have it. It's going to always be there. Except usually like 2 days before an exam, I take it down just to kind of mess with you. It's funny. All the videos don't work anymore. They're great for putting you to sleep too, the videos, I've been told. Okay, so that's the job of a programming language. What language do computers speak? Go ahead. Binary. What's binary? Yeah, zeros and ones. So how many of you would like to walk up to the computer and just say 0011100111? 00111? We wouldn't be very good at that, right? No. We wouldn't want the little 2-button keyboard? Just kind of tap it out? No. Because we'd suck at that, right? I've been programming significantly longer than most of you have been alive. I would suck at that. Okay? Now you're going to find out I'm a huge fan of binary, so you're going to get real good at binary in here too. But punchline is that's not for human consumption. It's kind of a magic trick, right? So I want you to understand binary, understand how computers actually are communicated with. But that's not an adequate tool for a human being to speak to a computer. So we're certainly not going to drop down to the computer's level. We're saying, hey, look, I speak English, you speak binary. How about I just come over to your side? And we're just going to do the zeros and ones. Now, it'd be nice if the computer came all the way to our side and spoke English, right? Why is that problematic? Why can't a computer speak English? In the future, maybe I actually started getting towards this point with machine learning, actually, but generally speaking, why can't a computer speak English? What's the problem with English? Go ahead. Yeah, that's it. It's not unambiguous. Yeah, English is a very powerful tool. All of our natural languages are very powerful tools that allow human beings to talk to each other. Okay, because we introduce a lot of nuance, right? And you could say the same words, and the way you say those words changes the meaning of those words, right? Make some sense? So it's not an unambiguous language. It's great for people. Okay, because we expect more than just the syntax. We want expressions and all this other stuff. It's not going to fly for computers. Computers need it to be precise, super precise. Now, like I mentioned a second ago, with machine learning, there might be a point in time where we can just sit there and tell a computer what to do by just speaking to it in English. It's already in the movies, right? Okay, you go back into like the 70s and 80s with Star Trek, and a lot of the things that were supposed to be high tech now we think are boring. We've had that for years. Okay, but same thing's true. We might be able to tell a computer what to do just completely in English and actually have it follow tasks as if it's a real human being. Okay, we already can tell our computer, like with Siri and Google Assistant and stuff like that, to like schedule appointments and that kind of stuff. So we have a little bit of that natural language stuff for computers, but we're going to say it's in the realm of possible to get up to human level, but we're not quite there yet. Okay, so English is not a viable tool, or any of our natural languages are not viable tools for us to tell a computer what to do yet. Okay, so these guys speak binary. That's zeros and ones. We said humans speak English. So now if we were doing a human level of fairness here, okay, I speak English, this dude speaks binary, we should just meet in the middle, right? So we don't have to give a name to it, but let's just say that there's some language X that is right in the middle between English and binary. The human version of fairness would say that's what we should settle on. Computer comes our way halfway, we come the computer's way halfway, and we just agree upon that language. Okay, but people are not fair. We're fair maybe, well, to an extent, we're fair with other people. This isn't a people. This isn't a person. This is a dumb machine that's going to bid to our will. You're going to come 95% to our side. Okay? We're going to get as close to English as we possibly can get while you can still understand what we're trying to say. That's what I'm going to say to you. That make sense?
Yes.
So, programming languages are as close to natural languages, like English, as possible, such that we can unambiguously describe the steps needed to solve a problem. That make sense? Okay, because we're greedy, and we're more important than the computers. We paid a lot of money for this thing, so it should do our bidding. Okay, and eventually we want to just talk to it, but right now we have to kind of like, oh, we'll learn how to program fine. Okay. So, we want our programming languages to be as close to English as possible. So now it's going to make you feel even worse, because I already said programming is hard. I told you why it's going to be hard. Now I'm also telling you at the same time that the languages themselves are really, really similar to English. Okay, so I'm giving you a language that's like English. I'm asking you to solve problems that in real life would be trivial for you to solve. Like if I gave you a bunch of change, and I told you to put all the quarters and the pennies and the dimes and the nickels together. As a human being, you could do that real easily, right? But if you had to think about what would the steps be that I would need to tell a computer to do to accomplish the same thing, it'd be a lot more difficult. Because it's not a hard enough problem for you to even think about what steps you need to take. You just do it. You want all the quarters? Here. Quarters. And then you throw them in the trash can so nobody uses quarters. Okay. We're still carrying around chunks of metal. It's funny. Yeah, so the languages are like English, which we're good at, right? Everybody in here feels like they're pretty strong in English, pretty strong in natural languages. Okay, so the programming language is not the problem. That's why I'll find it really funny. So, you guys get off the hook, although several of you rose your hand and said you had some programming language experience before. So you're always going to think whatever language you had is the best language, right? Okay. But when you get to be juniors and seniors and I start hearing crap like, well, I really like Java, but C# isn't, I'm just not a fan of that language. They're the same language. Okay? All of our languages today came from C. We're going to talk about that. Okay? These programming languages are all the same. Every now and then you'll have a language that kind of leans towards solving certain kinds of problems. But in general, all of our general purpose languages are the same. One's not any different or better than any other one. So when somebody says something like, oh, I'm good at this language but not another one, I know they're a useless programmer. Okay? So never say that. Right now you have the excuse because you're inexperienced. Okay? But if you ever find that creeping into your head as like a junior, probably in the wrong major. Programming is the skill set. The language is meaningless. Okay? That's actually what's fun about being a computer scientist. Is when a new technology comes out or a new language comes out, you don't have to say, well, I got to go pay all this money to take some course in it. You already know how to program. What do? You sit down and you say, with this particular language, how do I represent memory? How do I ask questions? How do I do repetition? So we have a slide here that I call the mapping. 100% of programming languages will have facilities for these three things. Memory is usually done through something called variables. Asking questions is something called conditionals. These are usually if statements. Repetition is done through something called loops, as well as functions, procedures, subroutines. They're all their synonyms for each other, let's say. 100% of programming languages have facilities for all three of these things. So if you bump into a language that doesn't have facilities for these things, it's not a programming language. HTML does not allow you to define variables, does not allow you to ask questions, does not allow you to do repetition. It's not a programming language. It's a data representation language. Nothing wrong with it. Okay? It doesn't make it like the last kid picked for the soccer team. Okay? It's a perfectly reasonable language. It's just not meant for programming. It's meant for data representation. That's why when you make websites, we have another language that goes along with it called JavaScript. That's the guy that lets you do the logic stuff, the programming stuff. JavaScript's a programming language. SQL, structured query language, also not a programming language. A lot closer to a programming language than HTML. It has some facilities that lets it get, let's call it halfway there. Okay? But for us, punchline here is that 100% of programming languages have facilities for these three things. Make some sense? All right, questions, comments, concerns, bribes. Yeah, we'll start bringing the tip jar. All right, so I'll give you another reading assignment over the weekend. Let me peek at it during lunch today. I'll probably just give you one section because I don't want you to get too far ahead of me, but I also want you to stay engaged in the book. So it'll probably be just the very next section if you want to go work on it right now, but it'll be at least the very next section, probably just the very next section, just to keep you engaged. Sound good? Also notice that there's already a homework assignment up. Every week you'll have Bible homework. All right? We're Concordia Christian School. We're supposed to incorporate a Christian worldview into the classroom. This should be free homework. What am I doing? I'm asking you to read one chapter from the Bible and write 1 or 2 paragraphs reflecting on how it relates to your major. Make sense? Okay. I'm not a theologian, so I'm not going to be able to teach you this stuff, but I'll let God do the work. Free homework points. Don't turn it in late. It's due by midnight on Sunday every week. Sound good? It's called Bible homework. Bible homework number 1. Yep, some of you may have already done it, but put a reminder in your phone so that you make sure you always get that turned in on time. You don't want to take a 0 on that assignment. All right, I will see everybody on Monday.